All right. So our last featured project of the day is Mitiq.
All right.
So this is internally developed at Unitary Fund, but we also have a really nice contributor community. So Mitiq is a Python toolkit designed to apply different quantum error mitigation techniques. And it's compatible with many front ends. So the internal operations in Mitiq are written in Circ, but it also works with Qiskit, PyQuil, Bracket, PennyLane, and OpenQASM. So why quantum error mitigation? Well, current quantum computers are noisy, so qubits interact with the environment. There may be errors in state preparation and measurement. Or gates may not be applied perfectly. So a lot of errors accumulate and results can become inaccurate, especially after a lot of operations. So you may have heard about quantum error correction in your quantum computing classes. If you haven't, that's okay. But error mitigation is different. So we're not directly correcting the errors, but we're aiming to reduce the effect of the noise. And we do that by compiling programs in clever ways. So we have a number of techniques to do that. We have zero noise extrapolation, probabilistic error cancellation, Clifford data regression, and a new one is digital dynamical decoupling. All right, so now we have a typical workflow in quantum software. So a user has a quantum program. It's written in Qiskit or Circ or PyQuil or Bracket or PennyLane or something like that. And then it's sent to the hardware backend, or it's sent to a simulator. It's executed, and then the user gets an expectation value. And right now, this expectation value is likely affected by noise. But with Mitiq, we put a thin layer between the user and the backend, between the quantum program and the actual execution. And so we generate a noise-scaled or probabilistically sampled quantum program as the error-mitigated quantum program, and then that's executed on the backend. And then the measurement results come back out, and there's an inference step, especially in the case of ZNE or PEC, and then you get a error-mitigated expectation value. So that is Mitiq in a nutshell, and I will show you our bounties. So we actually have a pretty good split between non-quantum and quantum issues. So the first two are for our documentation. So we'd like to have some thumbnail images on our documentation examples and just kind of improve the experience of going through the examples and contributing to Mitiq and that sort of thing. We also want to make our docs and function doc strings a bit more consistent. So we'd like someone to clean those up. Then we want to include specific backends in execute with shots. So there's a function in Mitiq called execute with shots, and that is basically like repeating your measurements a certain number of times. And so we want to, and Mitiq can actually instruct your executor function to do that. And we want to be able to specify the backend, the kind of backend we want in that. And then finally, we have a H2 example. So this is a simulation of an H2 molecule improved with Mitiq, and we want to make that example more interesting and more detailed. So we're hoping that someone will take that on. And I'll just quickly show you also So this is our GitHub project page. Don't let all of these files scare you. We're here to help and answer any questions that you may have. These are all of our awesome contributors, so these nice people will be here to help you if you have any questions. And we have 15 good first issues. So Mitiq is a great place to get started. And our office hours are going to be on Wednesday at 9:30 a.m. Pacific time. And I will be running those. So I hope to see you all there and see some really awesome contributions to Mitiq.